Hi guys, and welcome to the second part of my review, which is gonna be a teardown and hopefully an easy fix of this Huakko APS 3005D power supply. As you might have seen in my unboxing video or my first review, this unit arrived at my door broken. So now I'm gonna tear it apart and see what's broken. Hopefully it's an easy fix. And let's get right to it. First, be sure to unplug it. Then you have 10 screws around the case. 4 on this one, 2 up top, and of course 4 on the other side. Let's get it done. The screws are of course all threaded. Let's open the case. As I noticed in my previous review, the metal casing had some dents on it. You can see here one, and if I turn this one around, you can see a big one in here. And there's also a little one up here somewhere. And these two dents actually do line up with the transformer edges. So if you see, this is one of the dents, it's right at the corner. And this is another one of the dents. So there is a possibility that this thing was somewhere hurled or thrown, or I don't know what they did with it. But these two dents appear to come from the edges from the transformer. So if somebody was thrown this thing so hard that the edges of the transformer left markings on the inside of the metal casing, no wonder this thing arrived broken. And you can immediately see that the internals look quite a bit different compared to the Levolta. The transformer is huge. It's a lot bigger than the one in the Levolta. It uses almost the full width of the case. The rectifier is also mounted to the heatsink. The rectifier in the Levolta was mounted down to the metal casing. I also noticed the transformer is fastened down on all 4 corners, but also they're using these stupid spring washers to secure the nuts, but this way it actually doesn't work. It doesn't work if you have a normal washer, then a spring washer, then a nut, because the spring washer digs into the washer and the washer can turn freely against this bar. So the spring washers don't work in the first place, but especially in this configuration, it's completely meaningless. Just use the normal washer and the nut and secure it down with some thread lock or something like this. So this spring washer is completely unnecessary down there, and none of them work actually, so yeah, don't use them, they don't work. They have also the rectifier mounted onto the heatsink with the power transistors down in here, but as you can see, they mounted the whole heatsink to the fan itself. This is only attached to the fan, which is, I think they did it to isolate this heatsink, but it also is a bad idea, because if the heatsink gets too hot, it will melt the screws right out of the fan and fall down and short circuit to the case. This is probably the reason why they don't want you to run this power supply at full power for a long time, because I think this heatsink might get too hot and the screws will melt out. So yeah. Once again, you can see that they're actually using the fuse. This is probably the main wire, which comes from down here. And they also use heat shrink tubing, but they didn't shrink it down. It's just stuck on there. Oh man, come on. This is stupid. They didn't shrink it down to the so you can move it around. And now I noticed that the plug for the mains wire isn't completely in there. It moves a bit. As you can see, you can move it a bit. They hot snotted it up here so it doesn't fall off completely, but down there it moves. Yeah. You can once again see how this thing works. You got your hot wire coming in, going down here and into the main switch. which has also heat shrink tubing, but is also not actually shrunk down. Then it comes back and goes, this is the red wire, which comes from the main switch and goes down in here in the transformer. This down here is the primary winding. This goes back as the neutral to the mains wire. You have your ground coming in, going to the metal case, and also going to the front middle terminal down in here. It's the yellow wire. Then up top you have your secondary windings. You have these two red wires, they go to the display board up in here. You have these wires, they go to the power board in here. And as you can see, they're a bit short and they are right on the edge of the transformer. And if you flex it a bit, yeah, that's not a great sign. There's a real possibility that the isolation on these wires rubs through and that can short circuit something, and yeah, they really should have put something between the wires or something on the wires so you have another layer of protection between there. Yeah, not great again. You have on this side the 4 taps for the transformer, which come in at this side. You can also see the 2 relays down in here, and once again the rectifier and the 2 power transistors down in there. I don't think those 2 are shunt resistors. They are here for current limiting, for the worst case scenario. The shunt is actually this wire down in here. Now I'm looking for a loose wire because I still think that the issue is just a minor one, because they probably have tested this unit before it left their factory. So I think the damage to this unit was done during the shipping, and I'm still looking for a really easy fix, a loose wire or something like this. So I cut the zip tie off and see if all the wires are still connected to where they should be, if none of them are loose or something like that, and all appear to be in working order. So you can see this terminal also bent upwards because the wires aren't long enough. If you stretch that, it probably bent that out. That it's still to be on there, so I doubt this is the actual issue. But the plug is bent upwards. I think next up I remove the fan. Now let's take out the fan. This is the fan. I really didn't notice this during the review because I was sitting behind the camera, but as you can see, as soon as the heatsink touched the transformer, something short-circuited. And I think I short-circuited the buffer capacitors, which smooth out the ripple from the transformer. Because the power transistors are directly mounted to the heatsink has basically the same potential as the positive output of these capacitors, and because I touched it to the transformer, this short-circuited them and they discharged instantly and sparks flew. So this is what you see in the action replay. And these are the power transistors, so I'm gonna remove the heatsink. So the fan is a brushless DC fan, model LDH8025B. 80 is of course the outer diameters, 80 millimeters. 25 is the depth, 25 millimeters, and it's a DC 24 volts and 180 milliamps. So 24 volts. Here you can see the power transistors. They are 2N3055, just like the ones the Lavolta used. On the other side, you can see the 2 current limiters. There are 5 watts and 220 milliohms. I don't know if you can see that. It's difficult to read. Here we go. And interestingly enough, this power supply has a thermal element which measures the temperature of the heatsink and adjusts the fan speed accordingly. It's of course just a thermistor. If this thing gets hot, its internal resistance drops and the fan turns on because this thing is in series with the fan. Here you have the positive terminal for the fan. Don't know if you can see it, that's probably a 4 and 5, so it will probably switch at 45 degrees Celsius. So if this heatsink gets above 45 degrees, the fan probably turns on. It's nice that they have that in here. It is of course another part, and the LaVolta doesn't have that. And when we turned it on, it was actually quiet, so the fan isn't running during low load operations. So yeah, that's a good thing. Once again, I'm checking for loose wires. There's nothing on here. This is probably the base terminal. This is the emitters probably. And this is for the collectors because the case are just screwed down to the bare heatsink. There's no isolation between the heatsink and the transistors. Yeah, this is probably the collector. These are the emitters. This is the base, and I'm checking the wires and they are attached. So that's not it. Let's look further upstream. So now I'd like to take out the power board and take a closer look at it. I'm going to try to disconnect all these wires. They have this security shmoo on them to protect the connectors falling out. It does provide a little bit of resistance, but it doesn't stop me. So yeah, get these. This is the fan. These are the tabs from the transformer. The transistors are hardwired in, so is the rectifier. But there is another one down in here. I think this whole power board is just held in place by these trimmers. I don't see any screws or something like that. It's just floats in the air. So yeah, I'm gonna try to get the knobs off. And this one easier. Yeah, it was enough. Let's take a look. There must be some nuts. Yeah, there are nuts. Let's get them out. Let's see. Yeah, 10 millimeter. Fourth one. And the board slides right out. Come on. This is ridiculous. Oh, did you see that? That trimmer just fell off. This one. Ha! Come on. I knew it was something really easy. And as you can see, this trimmer is probably the culprit. It just fell off. And yeah, that's why it's dead. This is ridiculous. This is so stupid. They mounted this whole board just by these trimmers. And there was no support back here. And if you have difficult shipping and this thing vibrates up and down, it will just pop off these trimmers. And you see, this one has 2 plates. All the other one have 1 base plate. And this is, of course, just paper dipped in resin. And it's incredibly brittle. And it's so stupid that they think they can mount the board using these trimmers. Oh, that's just so dumb. No wonder this one broke off. So now that I have found my failure mode, I'm gonna probably be repairing this trimmer later on. It's 10K, I don't know if you can see that. I'm gonna zoom in. 10 kilo ohms. I probably can solder it back on and glue it back together. I'm gonna try to repair that later on. For now on, I'd like to continue with the teardown and take out this display board. Let's take out this board. Look at that. The mounting post for the screw broke off the front panel. Yeah. No wonder. So I don't know what they did with this tuning during shipment, but that's probably the cause for the failure. I now would like to take a closer look at this display board. You have, of course, 3-digit 7-segment displays. This is a rectifier. The power for this board comes in here from the transformer. It was this cable, plugs in here. You can see this plug got bent upwards. I don't know if this was during assembly or something else. We have here a voltage regulator. It's a 7805, so 5 volts voltage regulator, but it's not soldered down to the board. There is a big plate to solder it down to heatsink, and there was quite a lot of distance between them. Well, another fail. And these are, of course, again the analog to digital converter and 7-segment display driver. Yeah, here we go. 7107. This is the 7805. These are probably the trimmers to adjust the display value. Once again, the capacitors aren't glued down. Everything just hangs in the breeze. You can also see the production date of this board was the 17th April 2015. Version 0.0 of this board. As you can see, the model of the power supply, and they have also the display driver on in here. The soldering looks a bit crusty up in here. Next up, I'd like to fix this voltage regulator. I'm gonna solder it down to the board or screw it down to the board, and I'm also gonna glue the post back in. I also like to repair this trimmer and put it all back together and see if that fixes it. So I'm gonna reset here, bring in my soldering station, and get that fixed. First, I'm gonna desolder the rest of this trimmer and this voltage regulator. Sadly, the desoldering function on this solder station is quite noisy, so I'm gonna give you some music to listen to it and get right to it. During my desoldering, I ruined this pad a bit. I'm gonna solder in a wire from here to the base and resolder that voltage regulator back on. It's still quite a bit hot. Now that I'm done with the voltage regulator, I'm gonna try and disassemble this trimmer and repair it. Next up I'm gonna try and glue this piece back on so it looks like this. And then I'm gonna try and resolder those traces. I have this super glue. With that I'm gonna try and re-glue this board. So the super glue has set, and now I'm gonna restore the traces with this silver paint. It has a silver content of 47.25%, and it's fairly conductive, and I hope that's enough to restore the traces on this trimmer. I'm gonna try that out now, and let's see if that does the trick. I hope that's enough. I'm gonna let that dry up now, and afterwards see if that worked. Now I've let the paint cure for a few minutes, and I'd like to measure the resistance and see if it's actually fixed. For that I have my Gaussian multimeter, and let's see if that did the trick. So fingers crossed. And what do we have? 10 kilo ohms. Yeah! Let's see if the middle terminal still works. And what do we have? 4.6 kilo ohms. Let's turn it this way. What do we get? Of course less. 2.4. The other way. Let's turn it. And what do we get? 8.8, and all in all, again 10. So yeah, this trimmer is now fixed. This is of course just a temporary repair. I'm gonna look for another one of these and replace it. I just did this repair because I don't have one of these at home, and I'd like to repair this power supply and see if it actually works. Refocus. The trimmer looks good, and the wires down there aren't as ugly anymore. Now that I have repaired this trimmer and reattached this voltage regulator, I'm gonna reassemble this power supply and see if that fixed my problem. So let's get the display board in. Before I close it up, I'd like to notice that Up in here, they did put a metal insert in the plastic front panel, so that's fairly secured. It's a good thing they did that. And you can see that up in here, and this corner, you can see it. It's on both corners. There's a small tab in here to secure this board in, but as we have now seen, this is by far not enough to prevent it from vibrating so much and breaking this off. Now that I have completely reassembled this power supply, I am gonna plug it in and see if my repair actually worked. Let's plug it in and turn it on. And let's see if that did the trick. And contact. You could hear the relays clicking. And the voltage is at 33 volts. You see, I have to use up the fine adjustment to get it to 0 volts. So yeah, looks like we have a winner. Let's plug in the multimeter and see what we have here. Plus and minus. I doubt this trimmer is as good as new, but it's good enough for now, and I'm gonna replace it. Of course, I have to find this same exact part, but for now, this works. Yeah, first tab is at 5 volts. Second tab is at That's ridiculous. Second tab is at 20. Is at 22 volts. So it only has 3 tabs. So the first one is from 0 to 5 volts. The second tab is from 5 volts to 22 volts. Oh my. And the third one is from 22 up to get it up in there. Let's say you have this scenario where you need 5 volts and 5 amps. That means that the transistors in the back have to dump 17 volts and 5 amps into the heatsink. That's 85 watts. That's a lot of power. And I think that's the reason why they limit the full-time operational load at only 60%. Yeah, that's bad design. So let's test out the constant current mode. For that, I'm going to be using these load wires that I short-circuited. Have to turn up the voltage a bit. Here we go. And 5 amps. I can go a bit higher than 5 amps. 5.37. But yeah, this power supply is now fixed. It does the trick. It works like it's supposed to. All in all, I'm not too happy with this power supply. Although it has the plus of a regulated fan, so that the fan doesn't run at full tilt all the time. But it has all the same flaws that the Levolta had. And in addition to that, it has also the questionable heatsink mounting to the fan. Also the problem with the power board that it's only mounted up front to the front panel and dangles in the breeze down at this end. I'm definitely gonna be modding this and installing some mount to secure this power board so it doesn't flap about. Other than that, these alligator clips also had a major flaw with them. And my biggest issue is that it only uses 3 taps and that the middle tap has to cover such a high range of voltage. It goes from 5 to 22 volts. That means that under the worst case scenario, this power supply has to dump 85 watts into the heatsink. That's quite a bit of power. So all in all, I'm not too happy about this. Considering the price point and that I fixed it and it now works, I'm probably gonna keep it. I'm not quite sure if I would recommend that to another person who's buying that, because that wasn't the great experience I had with this one, because it was broken on arrival, and this power supply definitely has some issues. So next up I'm going to be comparing this Huakko APS 3005D power supply to the LaVolta and show you the differences between them. If you don't want to miss that video, please subscribe to my channel. If you have any questions or comments, leave them in the comment section below. And if you like this video, please leave me a thumbs up. That's it for this video. See you another time. Bye.